Hello, my name is Andrea Hernandez. I am an aeronautics student. My code is 2884007. I will start talking about ice and rain protection. The anti-ice system on board are designed to prevent the formation of ice in certain parts of the aircraft. These are the areas most affected by ice build-up, or when damage would occur if accumulated ice is released. Generally, anti-ice systems serve components around engine air intakes, or components that will not function properly if ice allowed to form. The ice and rain protection system enables unrestricted operation in icy and heavy rain conditions. For anti-ice, hot air or electric heating, it protects critical areas of the aircraft. The different subsystems of the protection system against ice and rain are: ice protection on wing, protection against ice, and the motor is an inlet, windshield, ice and rain protection. Currently, commercial aircraft have a protection system against ice and rain for which the station is located. In most cases, maintenance is according to a number of flight hours of the plane.
In the written project, we will have a theoretical framework chapter where we will explain the basic and necessary component for such system, a description where we explain the product of the project. In the following work, we will explain the importance of protection against ice and rain in the aircraft. Also, mention the different control systems and the importance of each component in order to counter the excess of ice. The ice rain project system allows unrestricted operation of the American in conditions of freezing and heavy rain. The critical zone of the aircraft are protected with not air of electric engine type of ice. Granular ice. It is opaque and white granular texture in an ice porous and light grained, clear of the glass ice. It is transparent and more dense than granular ice and present a greater degree of difficulty when removed. Frost. Frost perforation occurs principally in the wear when the plane is parked.
I'm going to talk about the wings anti-ice system, but first of all I'm going to introduce myself. My name is Juan Carlos Sereno Vázquez, a student of second year of aeronautics section B. My code is 003119, and as I told before, I'm going to explain the anti-ice system of the wings. In an aerodynamic profile, the single part who needs the anti-ice system is the leading edge of the wing, because we need to prevent the ice. This system works with hot air supplied by the intake air of the engine. The hot air pass through valves till the slats 3, 4, and 5 in each wing. The flight crew could turn on the system by a push button located in the overhead panel in the cockpit. And when you can see the draws to understand better. So as you can see, we have the push button and we have the system anti-ice, we have the part is wing, we have the push button. When you push it or when the pilot push it, the button turns with a green light, and we have a felt. This is a warning sign. When something is wrong with the system, the sign turns with a sound and a yellow light. And as you can see, we had a valve to provide with bleed air from the intake air of the engine. The system opens the valve when it's turned on and pass hot air through slats 3, 4, and 5.
This were the eyes, the icing or anti-icing system, which is all the button switches simultaneously control both sides, left and right. The eyes appears on the aircraft cams, aircraft central electronic monitors, the wind defrost, control valve open when the pneumatic symbol is available. On the ground, the icing control valve opens when for only 30 seconds. An amber flag comes and the caution signal is triggered on the cam if the position of the defrost control valve is required. Log the pressure is detected in the flight. The hot air from the pneumatic system has their last on the leading edge of each wings. Air is suppled through the bubble in the each wind. In flight, the hot air in the pneumatic system hits the three slots on the leading edge of the edge wings. Air is suppled through the bubble in each wind. The switch or button in the defrost and anti-ice panels control the bubbles when the aircraft is at the ground. The flight crew can initiate the for 30-second test to turn on or start the system. When the system detects a lack of normal operation, the frost or anti-ice bubble on the affected wind sides close automatically. When the ice system is selected, the EPR engine security radio is automatically reduced, and the EPR that is not used is automatically increased. If the electrical power supply fails, the bulb will close. Thank you, teacher. My name is Jose Samuel Alfaro Rauda, and I am a student of second aeronautic B, and my code is 052819. Thank you.
Hi teacher, my name is Celaya Lopez Joan Ernesto. My code is 051519, second Aeronautica B. I'm going to talk about ice projection in motor. It is a system that takes air from the engine and goes through freezing conditions. This head up that reaches the compressor, staying off the engine itself, that keeps the duct free of the freezing. The air of the fifth stage of high is the source of heat. This air passes through the butterfly valve anti-ice. The anti-ice valve is closing valve called a butterfly that is controlled from a switch in the cockpit. Thank you for your attention.
Hi teacher, my name is Jose Ariel Ponce Cortez. My grade is second aeronautics B. I start to explain for my part for the project. Well, I start. Each engine air intake is protected from air by separate air supply from that engine's high. Abbreviation HP compressor air is supplied through the engine. Air intake anti-ice valve. Engine antifreeze is manually selected by the crew and is available in flight or the run with engine running. After circulating around the entrance, the air is channel overhauled. The information from anti-ice button configuration is sent to a EABMM engine interface vibration monitor unit, which transit is to FedEx Full Authority digital unit engine control through the ARENC 42029, which will determine the continuous injection if it is necessary. Thank you.
Hi, my name is Sarah Ortiz. I am an aeronautical student. My colleague is 34 2017. I will start talking about its protection against ice and rain on windows. The wheel seat is responsible for providing the crew with the visual interface for pilots, being of vital importance. The protection against ice of the element can be done in different ways. Electric system. It is a heating system. Included the window powered by electric circuit. When using the system, the tempering system is very important. The subject the glass to thermal effect. The gray is pneumatic system. The two made on the bane the panel with those glass in the which the glass holds to sheets of the glass. Building with the hot air from the engine's compressor circulates and touch the system is the indices of the hot air coolant system. The dancing at the same time the system with the chemical. The system uses antifreeze flows or names of protection against ice. The plan uses electric heating to heat edge covered window. You in the paint window heating computer or edge to protect the system from overheating indicate faults. The window heater gun and automatic wind light on off the back is working out when the plane is in place. Manually before turn on the back when the crew turn on the pro or window heating. The whistle heater will allow energy when to grow our normally energy when it flies. The front and the middle automatically. There is only on level of heating for the windscreen. Windscreen outside the window, the car window are electric heating the newer or heating. Element incorporated in the transparent pump, the windshield, and for the electric system made of the indicated secret. A capital secret. Thank you.
Hello, teacher. My name is Emerson. I am an aeronautic student. My code is 011919, and I'm going to explain a little information about my topic. And my topic is heating. It's like a calefacción in Spanish. Okay, to get started, electronic having products, for example, sonda pilot, attack algal probe, start port, and total temperature prober. And the second part is the warming up of the gift and can be automatic when you both on flight. For example, when you when no when the pilot start the flight, other things. And the third part, pros and the windows are being permanently hardened to blue, right, and turn on, and also are to expand electronic from window screen wipers in the operate with a control. It's like another object. For example, the TV for the control you can use, for example, uh, drive drive the object. And for the finally part is the crew can apply spray to repel ram from the windows help that interrupt that vision, because when the pilot start flight you can see a lot of things, for example, for the trees or other things. But when you put the spray you can see. This is my topic, teacher. Thank you.
ATA rebels that for the engine uh, nestled and the slabs 3, 4, and 5 of each with aircraft uses hot air, and this system can be activated on the top pane of the car. Train consists of giving a full explanation of the usage, handling, and operation of the important system to reduce the impacts of the climate. The description and explanatory video which be made among the group, in which we will have its limit time of approximately 20 minutes to publicize and expose the subject that as corresponded to us in the same which will explain what the ATA treaty consists of. Wiper selector. Each rotary control manipulates your windshield wiper. Right repellent button. Each button controls the application of the right repellent fluid and your respective side of the windshield. Right repellent pressure indicator. This needle shows the pressure of the nitrogen in the right repellent. When repellent is necessary, the needle is located in the yellow sector.